Elon Musk may have kept something from his fans regarding the valid reason why the Starship was invented. It may not just be a matter of traveling to or populating Mars. Elon Musk may have envisioned something exceptional about Mars, so he has spent a lot of time and money creating the Starship, testing it to ensure everything works properly. Stick around as we reveal the untold hidden story of why Elon Musk created the Starship. Consider the size of the Starship and the number of Raptor engines it will employ to push itself from the ground here on Earth over the Earth's atmosphere and into space for 7 months. This alone begs for the question, why is Elon Musk working his ass off and putting himself through so much stress to arrive on Mars? Musk's motivation for developing the Starship and its 33 Raptor engines is for the benefit of humanity. He intends to create Earth 2.0, which is Mars, a friendly world where humans might visit and live much as we do here on Earth. Consider the noise produced by extensive industrial facilities, highway vehicles, automobiles, and vast construction projects. All of this is generating severe health issues for humans. One day, it might get out of hand and humans will die from inhaling dangerous substances from chemical industries and military missiles. So the Earth may become poisonous and deadly one day, but where would humanity go to? Or do we stay back on Earth and die like fishes in polluted water? Obviously not. That's the solution Elon Musk is trying to provide to the world, to make Mars a human-friendly environment where we can relocate if anything happens to Earth, whether it will happen or not. One of Elon's main goals is to make humans tour around space, get used to the environment, get used to the sky, and travel above the Earth's orbit in a quick flight. This is the hidden factual story behind SpaceX's decision to build a Starship. But why did SpaceX choose stainless steel metal over other excellent metals to build the Starship? Equivalent to stainless steel, what material could be more effective and less expensive for the SpaceX Starship rocket? Is it only the low cost of stainless steel that provides an advantage? Let's find out the proper answers to all of these questions. To truly grasp why SpaceX is now employing stainless steel, keep in mind that the company did not begin with it. The original plan for Starship was to make everything out of carbon fiber. They even created prototypes. That tank is one of the enormous carbon fiber structures ever built. It was afterward pressure tested to destruction and shown to be perfectly capable of holding liquid oxygen at 8.5 bars. They developed this massive cylinder to produce the carbon fiber body parts that would also form the rocket's exterior. They even developed a carbon fiber test piece and had constructed a tent plant in the port of Los Angeles to begin production in September of 2018. So you might be wondering, how do we end up with just a few months later? Although carbon fiber is lighter and stronger than stainless steel, it does have certain drawbacks. Carbon fiber is difficult to deal with. It cannot be cut and repaired. It must be made in its ultimate shape from the start, including any openings, holes, etc. Otherwise, everything you do later will weaken the structure and will not be patchable, requiring you to rebuild the entire portion from the ground up. At low temperatures, carbon fiber becomes brittle, especially at the cryogenic temperatures required for LOX and liquid methane. The last thing you want is for your tank to become brittle when it's cold enough to contain what you're putting in it. So suppose you want a carbon fiber rocket that can re-enter the atmosphere, where it must withstand temperatures as high as 1750 Fahrenheit. In that case, you must put a significant amount of heat shielding on the outside of the carbon fiber. It must be a solid covering. Even a tiny gap will result in carbon fiber burn through, and then, as previously stated, the entire rocket must be replaced. Carbon fiber also conducts heat very well, necessitating a double-walled container with tanks inside a barrel. This doubles the quantity of carbon fiber required for your rocket. The outer must be strong enough to endure the pressures of re-entry and landing, while the inside must be strong enough to handle the weights of pressurized tanks and be isolated from one another. Carbon fiber is tough to produce. Massive mandrels are needed to wound the precursor sheets around, and then the whole thing is baked in a controlled atmosphere furnace for hours or days to generate the carbon fiber lattice. Finally, carbon fiber is a costly material to produce. Elon estimated that a carbon fiber BFS would cost $150 per kilogram to manufacture, and even with all the extra supports and heating shielding required, would weigh between 80 and 100 tons. So the best thing you can do with carbon fiber is a ship that weighs between 80 and 100 tons, which is prohibitively expensive to manufacture. At up to 100,000 kilograms into $150 per kilogram, you're looking at least $15 million in carbon fiber cost costs alone, without engines, flight hardware, computers, or anything. So in September of 2018, they were already looking at the prices, the speed, and the maintenance concerns and saying, this isn't going to work to construct a rocket that we want to launch 100 persons to Mars every 2 years. And here's where stainless steel comes into play. Stainless steel is inexpensive and abundant. More importantly, because so many industries use it, thousands of professionals know how to deal with it, as opposed to carbon fiber, where the skill pool is still limited to automotive and aerospace specialists. You could employ a bunch of guys who regularly put together water towers, throw them in a field in Texas, and see how long it would take them to weld together a prototype for a few tens of thousands of dollars. Elon's primary claim was that the cost of building a Starship out of carbon fiber was $150 per kilogram, whereas stainless steel was $3 per kilogram. The 100-ton Starship would only cost $300,000 in stainless steel, and instead of employing professionals at $250 per hour, you hire a bunch of tank welders at $50 per hour to put it together for you. If you make a mistake, you may either pound it out with a hammer or cut it out and weld over it. That is the actual stumbling block when striving to construct a reusable Starship. It is feasible to maintain. You may mend it by poking a hole in it. If you break a piece off, you may weld a new piece on. Because of this, you can modify the design on the fly. There will be no need to modify the original mold. When you learn something new, you may apply it to an existing item. And of course, there are a few more perks. At cryogenic temperatures, stainless steel, at least the 301, 304, and 30X experimental variants used by SpaceX, becomes more vigorous. As a result, when the gasoline and LOX are loaded, the tanks are more potent than at room temperatures. It took some time to perfect the welding procedures. Still, the tanks now contain 8.5 atmospheres, enough for the 40% safety margin over the projected 6 atmospheres of pressure predicted during flight and the safety level necessary for human flight. Furthermore, stainless steel does not rust when exposed to water, so there is no need to paint it. Finally, 301 stainless does not begin to lose strength until it reaches 1500 Fahrenheit. That implies you can almost return from orbital velocity with no heat shielding. It implies that you only need to provide minimal heat shielding to the re-entry side, and that even if some heat leaks through due to the phenomenon known as stagnation, there's no danger of melting through the Starship. Even if it did, you could still mend the ship on the ground, which carbon fiber makes impossible. They've effectively matched the mass of a carbon fiber Starship without all the problems by discarding the ultralight carbon fiber in favor of the considerably more useful stainless steel. And they can already create a Starship in Boca Chica in about 2 weeks, whereas it may take that long to manufacture a single barrel section of a carbon fiber ship. The CEO of the private space company restated his broad concept of populating Mars, but he revealed few specifics about when Starship might reach orbit. Mr. Musk's presentation brilliantly sketched his vision of humanity's interplanetary future. Still, he was more reserved about the practical aspects of the giant SpaceX rocket Starship, which is key to those and other aspirations. The Starship must overcome severe technical barriers before it can go into orbit or complete a contract worth billions of dollars to put NASA astronauts on the moon, let alone colonize Mars. With all the noise trending everywhere about humans colonizing Mars, do you think it'll happen in this century? Also, take a look into SpaceX's Starship and its super heavy landing trick that has been finally shown.